Imagine standing on a frozen lake just north of the Arctic Circle. The only noise comes from a gentle wind playing with the pine tree in the forest behind you. In front lies a vast and flat expanse of snow covered ice stretching away into the distance until it encounters the dark. A haphazard barrier that is more forest on the opposite shoreline. Above that forest is darkness, an ink black sky, dotted with more stars than you had ever believed possible. Suddenly, somewhere in the northern sky, a green smudge of light begins to materialize and slowly manifests itself into dancing star roads of shimmering green light which skip across the darkness of space. These images, filmed from the International Space Station, captured the most spectacular natural light show on the planet Earth. But what caused the northern lights or the Aurora Borealis? In the center of the Earth, you will find hot molten iron just rolling around under tremendous gravitational pressure. That effect creates magnetic field around Earth, and that made Earth a really giant magnet. That forms what called magnetosphere. It's actually a very good thing that we have it. Turns out, sun gives more than just a light. The sun is so hot that it exists in fourth state of matter. That is solid, gas, liquid, and then plasma. And in plasma, ions which are positively charged atoms and electrons just freely float around one another. And these particles have such high energy that they escape the sun's massive gravitational field and start their journey toward the earth at something like a million miles an hour. That's called the solar wind. And that's where the earth's magnetosphere comes into picture. It's like a shield which is protecting us from this solar wind for billions of years. The magnetosphere sends those particles around the earth and we are safe. But sometimes magnetosphere overwhelmed by a new wave of particles. This event is coronal mass injection, and it happens when sun shoots out massive ball of plasma into solar wind. And when this coronal mass injection collides with earth, it overpowers the magnetosphere and creates magnetic storm. This heavy storm stretches the magnetosphere until it snaps back, throwing some of the detoured particles to our earth, and they start their journey into earth's atmosphere. In atmosphere, they interact with nitrogen and oxygen. An electron transfer their energy into this atom and excite them. But the thing is, they don't want to be in this state, so to calm back down, oxygen and nitrogen shoot off some of this energy, which they do in the form of tiny packets of light called photons. Different atoms into atmosphere each gives off different colors. Excited oxygen is what gives off that familiar green and red color. But there is also nitrogen up there, and it can give off a really amazing mix of red and blue light that makes the sky glow this incredible purplish pink. We can only see this happening at night because during the day they tend to be outshined by the sunlight, but it's happening all the time. And don't think it's only limited to Earth. Any planet with a sufficiently dense atmosphere that lies in the path of the solar wind will have auroras. Venus has no magnetic field and so experiences irregular shaped auroras, while planets with magnetic axis very different from their rotational axis have severely distorted form of the aurora oval. Auroras have been photographed on Jupiter, Saturn, and even on some planets' moons. Our moon doesn't have an aurora because it doesn't have the requisite atmosphere. But with spectacular lights also comes the threat disruption to our technological infrastructure. Solar wind are so powerful that they cause damage to satellite and disrupt the flight path of planes around the poles. These aurora are constant reminder that Earth's invisible layer protecting us for billions of years and giving us this beautiful phenomena. And that's pretty amazing. Peace.